Lesson will be over order of operations. So before we do that, let's talk about prime factorization. Prime factorization is like factor trees. The keyboard of a piano has 88 keys. Generate the equivalent prime factorization of 88. How can you rewrite 88 using different factors or different multiplication numbers that you multiply together? Factors that you multiply together will equal 88. So you know what? I'm going to make a factor tree because it's a prime factorization factor tree. So I know 88 can be broken up into 2 times 44. I circled 2 since it is a prime number. What is a prime number again? A prime number is a number that is 1 in itself. 44 can be broken down in 2 times 22. 2 is a prime. 2 times 11, 22 can be broken into 2 times 11. Is 11 prime? 1 times 11. I can't think of anything else. So what factors make up 88? 2 times 2 times 2 times 11. Can I rewrite this using an exponent? 2 to the power of, 2 repeats 3 times. So 2 to the power of 3 times 11. That is the same as saying 88. So, there are two types of calculator. You have a simple calculator and a graphing calculator. In a graphing calculator, it will follow all the rules. A simple calculator would just multiply or add or whatever it does just as it sees it. So, if you have a regular calculator, it will say that this is 27. If you have a scientific calculator or graphing calculator, it will say the answer is 13. Why does it differ? In the simple calculator, it does 7 plus 2 is 9, times 3 is 27. But with a graphing calculator, it does 2 times 3 is 6. Then it adds the 7, so it is 13. So the reason why we have order of operation rule is so a long time ago, mathematicians created this order operation rule. So when they see an expression such as these, everybody follows the exact same rule, so everybody gets the exact same answer. Because as you can tell, with these two different calculators, we came up with different answers. So we needed to use a prescribed set of rules, set of operation rules, so that we all get the same answer. So again, a simple calculator, those cheap dollar calculator, will say that the answer is 12. However, a scientific graphing calculator will say the answer is 17. Why is that the case? A simple calculator will add 10 plus 14 is 24, divided into 2 parts is 12. But however, a graphing calculator will see these as 2 terms. This is 10, the first term. The second term is 14 divided by 2 is 7. So 10 plus 7 is 17. Next question. A simple calculator will say that the answer is 44, which is wrong. A graphing scientific calculator will see these as 2 terms. The addition is an operator that separates the terms. 3 times 3 is 9, 2 times 4 is 8, so 9 plus 8 is 17. So, we have all these different examples. I am not going to be talking about PEMDAS, or please excuse my dear Aunt Sally, or using GEMDAS, or in some countries, I think in Great Britain, they use BODAS, where it's just brackets, BEMDAS, brackets, exponents, multiplication, division, adding, subtracting. Because we realize that it confuses a lot of kids when they see the multiplying, dividing from left to right, and adding, subtracting from left to right. So there is another way to do it, a more algebraic way to solve order operation. So you circle any additive and subtractive operators that are not in the grouping symbols, such as grouping symbols are parentheses, brackets, or these little symbols. Now you solve for the terms. For example, what does that mean? You are given a problem 7 plus 2 times 3. What operators, what additive and subtractive operators do you see? I see the plus, so I circle it. So I separate it into 2 terms. The first term is 7. The second term is 2 times 3. So I solved for the first term, 7. 7. I solved for the second term, 2 times 3 is 6. So together, 7 plus 6 is 13. So some of you may learn it as PEMDAS, or please excuse my dear Aunt Sally. I know I'm not going to really talk about that, but in that one, you do the parentheses first, there aren't any. You do the exponents next, there aren't any. Then you do the multiplication division, but you have to do it from left to right. That's where a lot of kids get confused, like left to right. They always forget the left to right. They always say multiply, then they think it's divide. They think it's parentheses, exponent, multiply, divide, add, subtract. No, multiply, divide. It follows, it's on the same level. So you do this as 6. 7 plus 6 is 13. Same answer. Let's try another example using operators and terms. We have this long expression. An expression is like a math sentence with symbols and numbers and operations. So we have parenthesis, grouping symbol 75 divided by 3 minus grouping symbol 7 minus 3 square minus 1. So do we see any additive or subtractive operators? I see a subtraction and subtracting. So we're separating this into 3 different terms. The first term is 75 divided by 3. The second term is 7 minus 3 square of it. And then our last one is 1. So let's solve each term. The first term, 75 divided by 3 is 25. Whoops, it's 25. The second term is this one. 7 minus 3 is 4, but what's the square of it? 4, repeat twice. The 4 repeating twice, so it's 16. And then in our third term is just 1. So what's 25 minus 16? 9. Minus 1 is 8. So let's practice some now. So generate an equivalent expression for each using the order operation. I see the operators, the additive and subtractive operators of minus and plus. So what terms do you see? I see 25 as the first term, 14 as the second term, 3 as the third term. Do I need to do anything with these? I can't. So 25 minus 14 is 11. 11 plus 3 is 14. Number 2, I see an additive operator. I circle it. So I have 42. The first term is 42. The second term is 6 divided by 2. What is these? Can you help me evaluate or simplify this term? 6 divided by 2 is 3. So 42 plus 3 is 45. Question number 3. 39 times grouping of 15 divided by 3 minus 16. Circle the subtractive operator. The first term is this. So I have 39 times whatever this is. What is in this symbol? 5 minus 16. So let's solve for the first term. 39 times 5 is 195 minus 16. What is the 195 minus 16? That's 9. 179 is the answer. Number 4. 48 divided by 8 plus 5 groups of 7 minus 2. I see this additive operator. So the first term is 48 divided by 8. The second term is 5 groups of 7 minus 2. So 48 divided by 8 is 6. What is 5 of this group of 7 minus 2? 5 groups of 7 minus 2 is 5. What's 5 groups of 5? 25. So 6 plus 25 is 31. 31. There. Number 5. Question 5. I see an additive operator. The first term is 7 squared. The second term is 6 times 2. I'm going to solve the first term. That 7 squared is 7 times 7 because it's 7 that's repeated twice in the repeated multiplication, which is 49. The second term is 6 times 2 is 12. Together, it adds up to 61. Number 6. I see a subtractive operator. The first term is 34. I cannot do anything with that. The second term is this, 8 squared divided by 4. 8 squared is 8 times 8, that's 64, divided by 4. 64 divided by 4 is 16. So what's 34 minus 16? Regroup. 18 is the answer. Number 7. Do you see any additive or subtractive operators there? I don't. So let's just solve it. 45 divided by 3 is 15. 15 times 2 cubed. 2 times 2 times 2. Because 2 that's repeated. In repeated multiplication, it repeats 3 times. 2 times 2 is 4. 4 times 2 is 8. 15 times 8, I believe, is 120. Number 8. Do you see any subtractive operator? I see right here. So let's look at this. So in this one, we just see a minus here. So I'm going to circle that one. But first of all, the first term is this. 4 groups of 5 squared minus 12. And then we have our last term 6. So we know we can't do anything with that. So we need to solve this. So it's 4 groups of what? In here, in this grouping symbol, we see another subtraction operator. What is 5 squared? 5 squared, so the first term of this one is 25 minus 12. So what is 4 groups of this? 4 of what? 25 minus 12 is 13. So I'm still solving for the first term. 4 groups of 13 is 52. 52 minus 6 is 46. So let's go back to this one. This is a very complicated question. So we have our first term, and then we have our second term. Our second term is 6. Our first term is saying, what is 4 times the quantity or group of 5 squared minus 12? 5 squared minus 12 is 25 minus 12, or 13. 4 groups of 13 is 52 minus 6. Where are the parentheses? Mrs. Pink wrote the following expression on the board. She realized that she forgot to include the parentheses. Shame on her. If Mrs. Pink knows that the expression is equal to 30, now it's an equation, where should she place the parentheses? Let's think. If I put the parentheses right here, the operators are here and here. 3 plus 11 is 14 minus 5 divided by 2 is 2 point. I'm going to stop right now. The answer is a whole number. So I know I'm not going to be working with decimal, so I'm not going to put it there. Well, where should I put the parentheses? Let's put it right here. The additive operator is here, here. So the first term is 3. The second term is 11 minus 5 is 6, divided by 2 is 3. Then the third term is 24. Hey, it adds up to 30. So she should have put the parentheses that groups the 11 minus 5. And last but not least, Peyton and Mackenzie were asked to simplify this or evaluate it, solve it. One came up with 23, the other one came up with 35. Who is correct? Circle the additive or subtractive operator. The first term is 3. Can I do anything with that? No. The second term is this. 4 groups of, what's 6 minus 1? 5. So what is 4 groups of this quantity? 5. 20. So 3 plus 20 is 23. Peyton is correct. If you look closely at this, shame on this person. She added the 3 and the 4 together and came with 7. Remember, this is a term. This is the first term. This is the second term. You're not mixing it right away. They're separate terms. So what we learned is order operation. So what we need to do is circle any additive or addition or subtractive or subtraction operators. Then it breaks the expression into different terms. first term, second term, third term, fourth term. Then you solve each term, and then you start adding and subtracting whatever left you have left.